Well, welcome everyone. This is work cycle sprint 3. It's the last sprint of our Surfliner work cycle. And today we're pretty excited to talk to you in our sprint review. And so we've got really 4 components to our sprint review today. First, we're going to be talking about the progress we've made about moving our discovery feature forward, both in terms of components and APIs. And we got some nice demos to check out there. We'll also be looking at a quick demo from Lark, which I'm looking forward to. We're going to be talking a little bit about our critical path Comet features and progress, and then wrapping up with stabilizing our infrastructure and what that's meant for our QA and data ingest preparedness, and then also talking about some fun, unexpected changes from some vendors in the ecosystem. So without further ado, I think we're just going to hand this over to our Daylight team and check out some of these demos.
Hello, my name is Elisa Pierce, and I'm going to give you a glimpse into some of the progress we've made on our facets. Let's see. Awesome. So the biggest change is our API is now delivering data concerning our facets. So we now currently get facets alongside all of the other information and data that we're getting out of Comet. So, or out of ADR Lite. And what that means is inside of Daylight, our components now have facets associated to them. Right now, it's just showing these links don't actually do anything just yet, but we do have some data now appearing. And this will help us, I believe, get to that next stage where we are fine-tuning our facets and ensuring our search results are user-friendly.
And the API does
That's,
return the information needed to build those links. We just haven't gotten quite there yet
yeah,
in the UI.
exactly. Exactly. Um, and that's it. It's a real quick one today. Our facets is also appears on our homepage here. And yeah, this will soon be integrated into our ADR Lite dev page, and then yeah, hooking up those links so that they link appropriately and show the appropriate results. That's it for Daylight.
All right, Lark, would you like to give us a quick demo?
Yeah, I'll go ahead. Let me share my screen here. This is going to be a kind of manual demo because we don't have all of the pieces to do this live in production. So this is just on my computer right now in the development environment. But this is Lark. When you just load it, it just gives you a version string, but we're going to see if we can get it to do some other things. This right here, YAML file is in the Lark directory. And this is very close to how Lark sees authorities internally. So we have some pref labels here, and they have these nested properties. They can have language tags. You can have multiple of them. This one doesn't have multiple, but so this is what things look like in Lark. And we're still ironing out, I think, the details of how we turn this into a CSV. But because we have this YAML file right here, we decided to go ahead and try getting this into Lark, seeing if we can get this to display through the system, and then we can have conversations about, okay, how are we expressing all of these properties in a CSV? How are we doing language tags in a CSV? The thing we have right now is really kind of hacky. So there's probably improvements to be made with all of those aspects. So I'm going to go ahead and do that. We have this little rake task you can run, and it throws up a deprecation warning that doesn't matter and then does its thing. Um, and we don't quite have the search controller up yet, so I can't actually search for these in Lark, but I should be able to view them. So I'm going to go ahead and get the list of IDs that were ingested through the console, and then I'm going to go into Lark and I'm going to try navigating to one. Um, and then you can see it right here. We have the pref label, we have the alternate label. It has a language and a value. There's the hidden label, exact match, close match to the Wikidata terms. And I'm doing this in Firefox because it gives a kind of nice JSON view. This is what the raw data looks like. But yeah, so that's what we have right now. There's code paths in Lark for searching right now on pref label and alternate label, I think. We probably also want to be able to search on exact match, I would assume. So, th getting those things hooked up and connected, I don't think is going to be a huge amount of work. And then once we have that, it'll be really easy for us to just to start loading some data in this format, and then we can start querying it and testing it, and then also pushing forward with those conversations about how do we do this in a CSV, and getting those built out. So that's what I have, but that's what we got done this sprint.
Thanks, Margaret. It's really nice to see that new functionality there. Awesome. All right, I think that would be the cue for the Comet team.
Yeah, so we continued moving forward on knocking off some of the features, the smaller features that people had requested. We also made some progress on requirements analysis for some of the bigger things, especially some places where we're still, I think the two campuses were still talking past each other just a little bit on complex objects and ordering and uh, access controls. So we haven't fully resolved all of those things, but I think we have a lot of things are much more clear than they were, and we're hoping to get that planned at a higher level of detail for our next sprint. And then we'll be really close to having the MVP features, I think, for both campuses. Yeah. Do you want me to talk about the Comet related infrastructure stuff at all, Michael, or are you going to do that?
Sure, I'd be happy to talk about the testing and kind of fixes that we did there and invite you to jump in as you see fit. So one of the primary areas that we put some effort into is sort of stabilizing our environments, specifically around ingest. And a couple of reasons that's really important is the issues that we're presenting were a little bit unreliable in terms of like when something would fail during an importer, which, as you can imagine, would drive folks trying to test it a little bit nuts. Also, those trying to find the issues was driving us a little bit nuts. And so what we did is we applied a pretty structured approach to find out where really we were running out of memory and what we were really being bound by. And so I think the result of that is our environments are quite stable with not only small but rather large ingest files. And thanks to Chrissy for trying to give us sets that will break our importers. Happy to report that these very, very, very large TIFFs are not breaking anything. And we think we've got some really good patterns to model what's going to be happening for us in sort of production, right, as we start to ingest those. What we learned was, given the resource allocations that we were using, we were able to sort of realize in some cases like a 5x increase in performance. So if you think about it with regard to when you're testing, that brings a 25-minute job down to 5 minutes. And it gives us a lot of inherent to the infrastructure today, that scalability is already there. So it allows us to really dynamically set that per environment and have some really good thinking just around like long-term, what does that mean for us? Is that different during data migration or production ingest and different long-term? Do we want the sandbox to have the same resources as production? But essentially all put together, that gives us a really, really nice through line for once we get our ordering for bulk racks defined, being able to really model very large ingest jobs and monitor the stability of those, which gives us our sort of our through line to production right there from like a data perspective. Big thanks to everyone on the team who was also helping with that. And I'm going to invite David to say something there.
Yeah, no, I was just going to say, I think the way that we like got together and tackled this issue with the memory issues and these failing ingests was really great. Like, obviously, we hope we're not going to run into situations like that in production, but we really, I think, did a pretty efficient job of jumping on it, putting our heads together, figuring out what was going on, and solving the problem. And I thought that was really great. And I also like something that I think Michael alluded to, but maybe it would be worth saying more explicitly that came out of this is we really can see now how that our scaling does work. And so as we find like if we need to ingest a lot more content, which of course we will at some point once we're doing the big production migrations, there really is quite a lot of room to just throw more horsepower at this and be able to process more stuff more quickly. we didn't explore the outer limits of that. I'm sure there are some, but we could potentially handle quite a large volume of data with this, and I think that's a really great thing to learn here.
David, we just need a cluster that we can tip over, and I would be happy to test those outer limits. Thanks, David. All those comments are really helpful. Appreciate it. So I think if that's it there, I'm going to turn it over to Alex and Matt to tell us about some important unplanned work and some of our fixes around that, or thinking. Alex, Matt, would you like to talk a little bit about our Bitnami and container registry infra work?
Sure.
Would
So,
like to is maybe the wrong phrase, Alex.
so we deploy into Kubernetes, as most of you probably know. We do that using Helm charts, which are essentially configuration files that orchestrate how the Docker containers are deployed into Kubernetes. So it handles how many are deployed. We can do scaling. It handles what environment variables are loaded in. It handles restart policies. It handles all the stuff. And so we write our own Helm charts for Comet, Starlight, Shoreline, but for the kind of dependent services like Solar, Postgres, that all of the services rely on, we generally don't, because they're such common tools that charts have been written for them by other groups. And so we don't have to manage and maintain them ourselves. The ones we've been using were produced by Bitnami. We use them because they were kept up to date and they had charts for basically everything. And so they had a consistent set of conventions. So once you were using one chart, it was very easy to use another one because they had all the same patterns and styles. And so we use Bitnami charts for basically all of our dependent services. Then they got purchased by Broadcom. Well, they got purchased by VMware first, then VMware got purchased by Broadcom. And others can tell you about Broadcom and what that promises for the future support of these free Helm charts. But the upshot is we need to find a new method of deploying these dependent services. So that's an ongoing process, and a very unwelcome kind of surprise at the end of the sprint. It's going to throw a wrench in some plans because we have to shift our attention to this. Was there anything you wanted to add, Matt?
I think from an urgency standpoint, so like Alex said, we've been using these Helm charts for the dependent services for, years now. But the more urgent issue we've also had to address is that we've been using container images for those services, which they've also maintained. And they're essentially stopping free access to, I think, next week sometime. It's like August 22nd
28th, I think.
or 28th now.
Just
okay.
over.
And so there's a temporary fix, which we did work on in this sprint, and that will hold us over for a little, but by a little, I mean, we're going to stop having security updates for those images and things like that. So it's not great. So yeah, it's causing us to have to reevaluate this whole layer of our architecture and what it is that we're going to do about it. So
yeah, none of it is like it's not rocket science to get this to work. Like there's, other people have the same problem. It's also totally possible to do this with, like, all these projects have their own standard images that they publish. It just work because we've been relying on this set of stuff that follows a certain set of conventions, and now we're going to have to hand roll some things that were off the shelf and just deal with it piece by piece and test each piece as we update it.
Well, thanks, Matt and Alex. I know that's been a lot that's landed on your shoulders unexpectedly, but I just want to call out, I think you've done some really, really good, both short and long-term thinking there, and I'm looking forward to both sets of those conversations that we're going to have probably later this week. I think that might put us at the time for questions. Are there any questions?
Let me stop the recording, Michael. So if people are being shy about that, they still have a chance.